Hi, yeah, thanks. It's great to be here. It's a privilege to be speaking to you today. I'm really excited to share with you my thoughts around WebAuthn and why we should start forgetting about passwords. My name is Dechrai. I've been a software engineer now for about 20 years, just over 20 years, and my passion has always been around security and privacy. One of the things that really excites me about WebAuthn is that we live in a world nowadays where it's quite common to outsource all of the authentication to a cloud provider like Auth0, who will allow you to integrate an SDK with your application and get login and single sign-on and multi-factor authentication, all these mechanisms out of the box. But the credentials are all stored in one place. Now, arguably, it's better to give that to a company who's dedicated to making sure that is secure, but WebAuthn helps us one step further by making sure that the credentials can't actually be leaked at any point because they exist on these tiny little devices or in your phones or on your laptops. So the hardware authenticators become the mechanism that prove your credentials rather than remembering a password, for example. So I think WebAuthn is, the future of WebAuthn is that it's going to make our lives as users a lot easier and our lives as developers and even the infrastructure side of things a lot less stressful. So it can only be a good thing. Before we have a look in depth at what WebAuthn is and how it works, let's look at passwords and other credentials. Let's look at the characteristics that we look for in sets of credentials and work out where they sit, how they relate to each other, and what the pros and cons of each are. So when I look at a set of credentials, there are three main groups of characteristics that I look at to work out whether or not I think it's a good performing, a well-performing credential set. The first thing is it easy to use? Is it easy to remember? Is it going to be hard for somebody else to guess? Or in the case of where it's not something that's guessable, can it be easily cloned? The second thing is how easy is it to change? If somebody does manage to guess my password, for example, how easy can I change it? If somebody manages to get access to my phone, how easily can I change it? The change mechanism is really important. But if it's really easy to remember and hard to guess and really easy to change, those two by themselves don't help if they're also easy to intercept. So obviously we want any credential mechanism to be hard to intercept. So if it's hard to intercept, if it's easy to change, and if it's easy to remember and hard to guess, then it's a good set of credentials. Let's have a look at some of these credentials and see how they stack up. I'm going to use a very non-scientific mechanism here. I'm basically going to plonk onto a graph the performance that I think that each of these credential types have with the characteristics that we've just looked at. And I'm basically going to say, do they perform really well, really badly, or somewhere in the middle? Is it a bit of a grey area situation? And I've mentioned passwords already. Let's start there, because that's a credential mechanism that we're all familiar with, usually tied with a username or an email address or something. Password is something we have to remember, which means that they're increasingly or significantly hard to use in terms of the remembering side of things. They're also somewhat easy to guess, insofar that as if I have a password that's easy for me to remember, then it's either going to be one of many passwords that are quite common, or the length of the password is going to be such that a computer could iterate through and do a brute force attack and get to it relatively quickly. The easier it is for me to remember a password, the easier it is for a computer or a human to generate or guess that password. The ease of change, though, is something that passwords are probably the best at, which is not necessarily a saving grace for passwords. It's just a fact that a password is basically stored in a database or in some kind of storage mechanism somewhere. Ideally, it's going to be hashed so that it can't be reverse engineered from the hash. But to change a password just requires you to prove your identity and then provide a new password, which will then get hashed using the same mechanism and stored in the database table. So it's a hash and a database update, and that's all that's technically required to perform a password change. So changing a password, really easy. Intercept is, I'm going to put it slightly down towards the negative side of the grey area. It's becoming a lot harder to intercept because nowadays we're a lot more focused on HTTPS everywhere. It's more common to find even your standard blog that doesn't even require you to log in to view it will still be over HTTPS. And there are various other reasons why we run all our websites over HTTPS in terms of security and privacy and tracking and various other things. But it does mean that when the passwords are in transit, when we're sending details from a browser to a server, they're a lot more secure already than they might have been in the past, where it was possibly commonplace for less security strict web applications to encrypt those passwords in transit. But we still have an issue when it's at rest or before it's even sent. So if there's a malicious plugin in your browser, or there's a cross-site scripting attack in the application, then the password could be intercepted before it's even sent to the server. And once it's at the server, if it's not hashed properly, or there's a disgruntled employee who leaks the data, or a hacker who gets in and leaks the data, there are all sorts of ways the passwords can be leaked. And we're all probably familiar with the Have I Been Pwned website, which is run by a fellow Australian, basically a database of a whole lot of large data breaches and passwords that have been leaked, so that people are able to find out whether or not they've been affected by this. But the pure existence of Have I Been Pwned points to the fact that passwords are really are not a very secure credential mechanism for us to use nowadays. So we tend to layer it. Let's have a look at a different kind of credential that we can use. SMSs. We've mentioned SMSs and emails a little already. They're basically in the same kind of bucket. It's a message that gets sent to you somehow, and you can act on that message. Maybe you get sent a 6-digit code or a 4-digit code, or a password of some sort, a one-time password, or maybe it's a link that you click on, and that link will die once you've clicked on it, but it'll verify that you have access to the device or the email account that that message was sent to. So in terms of remembering, it's quite easy to remember. In fact, there is nothing to remember. You need to have your phone on you or access to your email account, but then that one-time code is something you type in, or the link is something you click. It's ideally one time, so nobody else can then use it in the future, but there's nothing actually to remember. It's also going to be quite hard to guess, because it's going to be random code each time, and the URL is going to be randomized each time, ideally. So in terms of hard to guess, easy to remember, scores pretty highly. Changing is about as easy as a password, or maybe a little harder. Essentially, it's just an email address or a phone number in a database field. But we need, as developers, when we're looking at the security side of things, to take extra precautions when changing a password, when changing an email address, rather, or an SMS, in that we need to make sure that if they change their phone number, for example, we send the user a message to the new phone to make sure they actually have access to it. We might also want to send a message to their old phone number saying, hey, somebody's just changed your phone number, so that if it was somebody who's not supposed to be changing this, that the original user's made aware of it. And the same counts for emails as well. If we're changing our email or our phone numbers or any kind of communication endpoints, mechanisms for the website to get in touch with us, we need to both verify that we have access to the new account, and the old account needs to be told that the change has been made. In terms of intercept, it's going to be harder to intercept than a password, but there are still a number of vulnerabilities. So I'm not going to put it into the green area. There are issues with email, not with email itself per se, but if somebody does have access to email, then they have access to pretty much any site that uses email as a password reset mechanism. So that puts us into a little bit of a dangerous territory. When it comes to SMSs, the S7 protocol, which is the mechanism used by the mobile carriers around the world to make sure that SMSs get delivered between networks, the protocol itself has a couple of vulnerabilities which are not necessarily easy to perform, but they do allow somebody, for example, to say, hey, I want to intercept an SMS going to Ben. So I know Ben's mobile number, I'm going to put in an S7 network attack to have any messages sent to Ben come to me instead. And in fact, maybe you could even set it to send Ben a different response, or still the same response, so there's nothing out of the ordinary, but intercepts are possible. So in this case, it's a targeted attack. They have to specifically say, we want to attack that phone number. Or in case of an email, they'd have to attack a certain email address, unless the passwords come up in a password leak, such as through Have I Been Pwned. So there are a number of issues, but certainly intercepts are harder than pure passwords. So I've scored it slightly higher. You can probably see that it's slightly more towards the green area there, slap bang in the middle of the grey area. And then we've got voice or biometrics. Maybe it's a fingerprint. The advantage with these types of credentials, the biometric related credentials, is I don't remember the last time I left home without my fingerprint or without my voice. Obviously, there are things that can change them, and from using them as a pure credential mechanism or as a sole credential mechanism, my fingerprint can get damaged if I'm doing woodwork. My voice can get damaged if I am singing a lot. Not that I sing very much, but maybe I've had a cold and my voice has changed. So there are various things that can change the credential, essentially, but it's not really something I have to remember. So in terms of easy to remember, hard to clone or hard to emulate, I'm going to score it pretty highly. In terms of changing, however, it's nigh on impossible. I can't change my fingerprint. I do have 10 fingerprints, so I can technically change which fingerprint I use to authenticate 9 times, but then I'm out of fingers. I can't go beyond that. Also, once one fingerprint has been leaked, I need to make sure that it's never used anywhere else, because I can't invalidate this fingerprint. If somebody has a fingerprint, and I'll talk about how that could happen in a second, we can't change it. I can't change my voice. It changes slightly over time. That's a different issue. But I can't say, look, my voice has been compromised, I need a different one. That's not possible. In terms of Intercept, I'm scoring it quite highly, but it's not quite in the green area because there are a couple of little issues. We know nowadays, and you might have seen it yourselves, some of these videos where there's side-on-side video where there's some general member of the public talking, and then on the other side there's an artificially intelligently created video of, let's say, for example, Barack Obama. And it's his face, his lips are moving in time to the words, and the words are coming out in his voice. And that's all computer generated using artificial intelligence based on what this person over here is saying. So technically it's possible to emulate voice. Technically it's possible to also emulate fingerprints. There's another story where somebody was able to take a high-resolution photo of a fingerprint on a glass, and taking that high-resolution photo into a 3D rendering software, turning it into a 3D model, and then printing it with a 3D printer using a material that was accepted by the fingerprint scanner as skin. They were able to unlock a mechanism using a cloned fingerprint. So it's technically possible, but in both of these cases, they are again targeted attacks. Like the SMS situation, you can only emulate one voice at a time. You can't just break all voices. You have to find the fingerprint that you need to unlock. So they're targeted attacks. The Intercept performs well in terms of it's hard to intercept, but it is still possible, and we need to remember that. And you've probably noticed that there are 3 main characteristics here of password types, and we call this multi-factor authentication. We have passwords, which is something that you know, something in your head. We have SMSs or emails, which is something you have. You have access to the email account, or you have the SIM card that's in your phone. And then we've got voice and fingerprint, which is something that you are. It's a biometric authentication mechanism. So in order to make users more secure, we now tend to look towards multi-factor authentication, where we need at least 2, possibly 3 of these characteristics. You can't have 2 password types or 2 somethings you know. You have to have 1 from each of these 3 columns. And they could be things like a PIN number, an access card, and a client certificate in the browser. But having, not the client certificate is something it's actually something you have, but you could have a voice, for example, still. So getting multiples of these factors make us more secure, and the downside to that, though, is that we're making it less convenient for people to log in. We're putting extra layers of security in, which makes convenience harder, and people are going to be slightly more annoyed at having to log in. So we have to balance the user experience journey here with proving who we are as users. So what you'll find is that maybe to access the system in the first place, you just need a username and password, and that'll get you in. You can see your dashboard. Perhaps if it's internet banking, for example, you can see your statements. But if you want to do a transfer, then you've got to give it a second factor of authentication. Maybe they'll send you a code via SMS, or maybe if it's a physical presence you're trying to log into, you'll need to use your fingerprint scanner to access whatever it is you're trying to get to. So we can do this step-up authentication where higher levels of authentication are required for more sensitive actions that we want to take. Let's consider not using passwords or anything that you know at all. And you might have heard of the term passwordless. This is where we get rid of the need to remember things. Obviously, you need to remember your phone or your hardware authenticator, but the need to remember things in your brain in terms of what was my password and when did I change it, these kind of things are thrown out when we look at passwordless. And if we look at just things that we are and things that we have, we can get passwordless authentication, which is a lot more convenient. People don't need to remember things. If you're using a different computer and you have a password manager, you don't need access to your password manager anymore. So we're making it easier for people to log in. But now we're also reducing the number of factors that we can use. So if we go purely passwordless, convenience is high, and we've still got good levels of authentication and credential checking, but we've lost one of the factors that we can use. So technically, maybe you could consider that it's getting slightly weaker for the sake of slightly more convenience or ease of use for our users. So let's bring in the FIDO security key now, and that's the things like these little USB devices or your mobile phones that have a hardware authenticator built in. These are what WebAuthn uses for authentication. The advantage with these is that they have a public-private key on board, which means that the credentials are always stored, or the mechanism for identifying yourself is contained within the key itself. This makes it really easy to use and really hard to guess. The public-private key pair, the only way of generating a signature of a payload, and we'll look into the technicalities of how WebAuthn works in a minute, but the ability to clone a public-private key pair is mathematically improbable. I'm not going to say it's impossible. There's probably some minuscule probability that somebody somewhere might be able to do this. But again, it would have to be a targeted attack. It's going to take a huge amount of computing resources. So we can essentially call it impossible. For most intents and purposes, it's impossible to clone a public-private key pair for the purposes of breaking a FIDO security key signing mechanism. In terms of changing, it's about as easy to change as changing your phone number or your email address on a website. You just register a new FIDO security key with the web application you're trying to log into, and if you need to, you can deregister the old one. Often you might find that it's useful for your users to have multiple keys anyway, because then if they lose one, they've got a backup. Maybe they have one in their pocket or on their keychain and one in a safe somewhere just in case something goes wrong. And that way they can use either of them to log in, and they have that backup mechanism, because the ability to recreate, like I say, the public-private key pair is so mathematically improbable that if they lost their key, they've lost their credential mechanism. In terms of Intercept, again, really high, and there's an additional thing that I'm going to add on. Like I say, generating public-private key pair or cloning it is so improbable that you're not going to be able to clone the public-private key pair. Similarly, when the signed challenges, which we'll look at in a second, and the keys are passed around, the public key is the only one that ever leaves the FIDO security key. So public keys are public. It doesn't matter if they're leaked. And the signed challenge is only good for one request anyway. So Intercept, even if you could intercept the data, it doesn't matter, because it's a single purpose, single use, and it can't be used against the wrong web application you're trying to log into. And this is a really important additional feature, is that it eliminates phishing attempts. You might find, and we'll have a look at what phishing actually, how it works in a second, but you might find that if you provide credentials to the wrong application, then obviously that malicious user is going to be able to use that data or the credentials to log in as you. Phishing is how that works. Let's have a look at that, in fact. So you've got a user, let's say this is you trying to have a lovely day watching videos at JSConf Korea. And you get an SMS or you get an email at some point. And I had one of these emails just the other day. It was from Google, and they said, you've run out of cloud storage. We're not able to back up your device anymore. Click here to upgrade your account to get more storage. Let's say you got one of those, but it wasn't actually from Google. Let's say it was from, let's say I was trying to get into your Google account, and I sent you the message, but it actually took you to a website that looked very much like Google. And to your brain, it felt like you're logging into Google, and all the messaging felt right. So you just clicked on it and you get this login page, and you provide your actual credentials to this website. But your brain doesn't notice that the domain is actually slightly different. So you provide these credentials, and the first thing I'm going to do as an attacker is I'm going to send you to a fake success page. I could send you to the actual Google website, and the likelihood is if you're a Google user because you logged in, then you're probably actually logged in already. So you'd get to the Google website after I redirect you there, and it would look like you'd successfully logged in. But there's a reason I'm using a fake success page. We'll come back to that in a second. Meanwhile, you've sent your actual Google credentials to me, or more likely to a script that I've got running somewhere. And that script is then going to take those credentials and pass them to the Google server and say, hey, I want to log in with this username and password to see whether or not they work. And in an ideal situation, what happens is I get a 200 confirmed, it's okay, yes, you're logged in, and I now have access to your Google account. I can change your credentials and hijack your account, or I could use your account for fake reviews or whatever it is that I want to do with your Google details. I now have your credentials. Now let's go back to the fake success page for a second. You might be aware that if I did try to log into your Google account, then Google's probably going to notice, and all of the larger websites and any of the websites out there that will check where you're logging in from will alert you if you're logging in from a system that has not been recognized. So you might get a message on the browser if you're doing this legitimately, saying, hey, it looks like you're logging in from a new device or from a new country. We're going to send you an SMS. Please enter your code in here to verify that you are who you say you are. This is the step of authentication that we were talking about before. Or maybe it's a push notification. We're sending you a push notification, hit the yes button, and then we'll log you in. So if that happens to me while I'm trying to log in as you, then if you get the push notification, you hit yes, I'm logged in. If you get the SMS, where do you put the code? So if I give you a fake success page that says, hey, I need this code, you type your code in, then I have your code, I can use that to log in. And the likelihood is, if in your brain you think you're logging into the real Google website, and you get the notification saying, hey, it looks like somebody's trying to log into your Google account, you're going to hit yes without noticing that down at the bottom it says you're logging in from Melbourne, Australia, which is me, not you. So basically what phishing is the ability to trick somebody to provide their credentials into a fake login page. Let's have a look at how WebAuthon's registration and login process work now, and how they stop the fake login page scenario or phishing from happening. So let's say this is you, and you're trying to log into my website. You go to your browser, you type in the URL for my website, you hit the register button, and you say, I want to create a new account. My name is Susan. So you provide the username Susan to my server. My server says, hey, it looks like you're trying to create a new account using FIDO or using WebAuthn. So what I'm going to do is I'm going to return to you, or rather to your browser, I'm going to send you a challenge. And this is some randomly generated code, some text, some data that I require a signed response for. Let's have a look at how that signature happens. So the data gets sent to the browser. The browser then uses the navigator.credentials API, which is the API available in the newer browsers to enable WebAuthn. And this navigator credentials API has two methods on it. The first one that we're going to look at is the create. It has a number of methods, but the first one we'll look at is the create method. And into it, we pass the challenge that got sent from the server, and also we pass in the web origin. So if you're looking at google.com, it'll say google.com. If you're looking at g00gl3.com, it'll have that in the web origin. So each key pair is now locked into the domain, and no matter how confused your brain might be, your browser is never going to get confused about the web origin that gets sent to the web as part of the WebAuthn login process. So that web origin is used by the security key to generate a new public-private key pair locked to that web origin, and then it'll take the challenge that it received as well, and it'll use the private key to sign the challenge, and then it'll return just that signed challenge and the public key back to the browser. The private key gets stored on the security key on the actual device, and only the public key gets sent back to the browser, along with a public key identifier or a key pair identifier and the signed challenge. The browser doesn't do anything with this other than send it straight onto the server. So when Susan has created her account, the final response to the server includes the public key, the public key ID, and the signed challenge. So my server can now say, hey, I know that Susan tried to create an account, and I know that I sent her browser this challenge, and I've just received this signed challenge in return, which I can verify is a signed version of the original challenge, and it's also been signed with the key pair that's associated with this public key that's come back. So essentially this is now, in effect, my password. It's the way that I verify that Susan is the person who's logging in next time. So into my database, I'll store Susan's username, the public key, and the public key ID. They're the 3 bits of information that I need to store. So now Susan comes back and she wants to log in. She's got an account already, and she says, hey, my username is Susan, I want to log in. And my server is now going to say, well, I know that there is a user called Susan already, and in fact, Susan's got this public-private key pair ID that I'm aware of. So I'm now going to send back to Susan's browser the challenge and also the ID of the public-private key pair that I expect her to sign this challenge with and return back to me. So I need to make sure that she has the same key available to her that was used when she registered her account. So we now call the get method on the navigator.credentials API. And into that, again, we pass the challenge, we pass the web origin, and we also pass in the ID this time. So the hardware authenticator can now pull out the public-private key pair, or rather the private key associated with that ID. They can use that private key to sign the challenge that got sent in, and then return just that signed challenge. Signed challenge goes back to the browser, and the browser then returns that signed challenge back to the server. So in logging in, Susan told me her username. I sent a challenge plus an ID. That ID referenced the public-private key pair that was used to sign the challenge, which is then returned back to the server. And I can verify that the signed challenge that came back is a signed version of the challenge that I sent for the login process, which will be different to the one that was used for the registration process. But I can also verify that it was signed with a key pair that matches the public key that I have on record already. So I'm not updating that. I'm using the previously stored public key to verify that the signature was generated by the same device. So it's essentially proving that the person who's logged in has access to the hardware authenticator, which in the case of some hardware authenticators might just prove that they have possession. But in the case of ones where, like the Pixel 2, where you have the fingerprint reader on the back, or maybe the MacBook Pro, where you need to touch the fingerprint scanner to activate the hardware authenticator, it also proves who's there, because while you don't know what the fingerprint is, you know that it was the same person who was able to unlock the key the first time. So I hope that's given you a bit of an insight into how WebAuthn works, how the flow works, how we manage to eliminate phishing attacks through the tying of the web origin to the public-private key, and how it makes us as developers more secure, the applications we develop more secure, insofar as we don't have to store credentials in our databases anymore. We're actually just storing a public key, which we can use to verify future signatures generated by the hardware authenticators that are used in the WebAuthn login flow. I'm going to be sticking around after this for Q&A. I'm more than happy to take any questions, and I'd also love to show you a demo using WebAuthn.me, which is a website written by one of my colleagues. I'm also available on Twitter. My DMs are open. Here's my email address. I'd love for you to get in contact with me afterwards, connect with me via LinkedIn. I'd love to hear your stories about the kinds of problems you're trying to solve, and just to generally connect. Thank you for your time, and I'll talk to you in the Q&A. Thanks.